AlKanes. AlKanes. It is a single organic compound, and it is one type of hydrocarbons. As you see there, hydrocarbons have four types: alkanes, alkynes, alkenes. And cyclic hydrocarbons, we will take their alkanes. The general formula of alkanes, it is CnH2n plus 2. For example, methane molecule CH4. If we put there 1 instead of n, we will see that be C1 H2 1 plus 2. 2 plus 2 equal 4, and as you see there, CH4. This table will show structural formula, name of compound, Latin prefix, and number of carbon atom for 10 members of alkanes. As you see there are 10 members: methane, ethane, propan, butane, pentane, hexane, heptane, octane, nonane, and decane. And it shows the structure: methane CH4, ethane CH3, CH3, and its number of carbon atoms C1 and C2, and its Latin prefix, for example, methane METH and ethane ETH. Type of carbon atom. As you see there are four types of carbon atom: primary carbon atom, secondary carbon atom, tertiary carbon atom, and quaternary carbon atom. The first, primary carbon atom. It is mean the two carbon atoms are attached together as following in ethane molecule. If you see there are two carbon atoms are connect with each other with a single bond. Secondary carbon atom. It means the carbon atom are attached to another carbon atom, as in the propan molecule. As you see there, this carbon atom are attached to another two, a right and left carbon atom. Tertiary carbon atom. It means the carbon atom are attached to three another carbon atom, as in the following isobutane molecule. See there, this carbon atom are attached to three another with a bond. Make it a tertiary carbon atom. Quaternary carbon atom. It means carbon atom are attached to four another carbon atom, as in new butane molecule. As you see there, this carbon atom are attached to four another, make it a quaternary carbon atom. Nomenclature of alkanes. The first starts with letter N. Then the name of alkane comes, such as propan, changed to N-propan. As you see there, this formula CH3, CH2, CH3. To start with the prefix iso, then the name of alkane comes, such as butane, changed to isobutane. The general formula of butane is CH3 double CH2 CH3, and when it's changed to isobutane, it's CH3 CH CH3 and the other CH3 up. The third starts with the prefix new, then the name of alkane become, such as pentane, changed to new pentane. The general formula as you see for pentane it's CH3 cubic CH2 CH3, and when it changed to new pentane it's CH3 C CH3 and CH3, one become up and the other down. Alkyl groups. The remaining group after removal of one hydrogen atom from an alkane is called as an alkyl group. Its general formula is CnH2n plus 1, and it's shown as minus L child. If you remember that the formula of alkanes is CnH2n plus 2. there were if you note there, change to CnH2n plus 1. That means the last hydrogen atom are discharged and changed to alkyl groups. As following, as you see there, look at the first molecule. It's for methane. The carbon are attached with a covalent bond with 4 hydrogen atom, and when it's changed to alkyl, it's discharged 1 hydrogen atom and stay the carbon atom with the 3 hydrogen atom and change to CH3 minus R. As you see at this table, it contains the alkane and alkyl molecules. See there at alkane. Methane, it's CH4, and when it's changed to be alkyl, its name changed to methyl and be CH3 minus R, and as to ethane, propane and n-propane. Nomenclature of alkanes. Nomenclature rules. Now this alkanes from IC to it. The first, choose the longest carbon chain to name. Then we number carbon atom by starting from the side close to branching. Name according to the number of carbon. See to this example, it's for butane. How I know it? I calculate the number of carbon. It's 4. And as the table I show in the last picture and in the next picture. As this table, see if you remember it. The butane, it's C4. Main, it's have a 4 carbon atom. As usual. The second, in order to determine the place of alkyl groups or functional group, we look at the number of carbon atom they are attached to. And 3, if there are more than 1 alkyl groups, they are named with respect to order in Latin. See, for example, see this methyl butane. How I know it? I calculate the number of carbon atom. It is 4. I know it's a butane from the table. And methyl, it is, if you remember the table of alkyl groups, it's this atom for methyl, it's alkyl of methane, CH3, and always I added the number of alkyl, then I added the number of alkane. And the last number 4, if there are more than one of the same group, then their number expressed by Greek number, di, tri, tetra, and penta, and mono. Before their grouping name, the number of carbon atom to which they are attached be written separately, as you see in that example. Dimethylpropane. See, it's a methylpropane compound, and we added a dry before it on the second picture. It's a trimethylpentanol. We added a tri. It's a compound for methylpentane, and we added a tri before it. Physical property of alkanes. The first, solubility. Molecular of alkane aren't polar, they are non-polar. Therefore, they are insoluble in polar solvents as water, but they dissolved in non-polar organic solvents as gasoline and carbon tetrachloride. If you notice it, they're the same, dissolve in the same as it, and don't dissolve and don't same. See there, it's the alkanes, it's not polar, and it dissolved in not polar the same, but don't dissolve in the polar don't same like water, and not alkanes dissolve in non-polar solvent as oil. Therefore, it is dangerous to be exposed to vapor of alkanes. The reason is that dissolved oil-like structure, such as cell membrane, does the destruction of lungs tissue and cause for you many diseases. The second one, boiling point. Boiling point of alkane increase as their molar mass increase. Methane, ethane, propane, and butane are gas at room temperature, while the other is liquid. As molar mass increase, also boiling points increase. When the number of carbon atom in molecule reach 18, alkane becomes solid. Alkane, no except. Chemical property of alkane. The first, chemical reaction. As alkane are saturated hydrocarbon, they have strong single bond. They are less active when compared to other organic compounds, as big amounts of energy are necessary to break their bond. Alkanes don't react with strong acid as sulfuric acid and nitric acid under normal conditions. They also don't react with strong base as sodium hydroxide or oxidation agent as potassium permanganate. Composition reaction. When alkanes are composed fully in air, they yield carbon dioxide and water vapor along with a smokeless blue flame. A great amount of energy is released. Therefore, alkanes are used as a fuel in industry and engine of motor vehicle, as you saw in the next page. As you see in this picture, see it's a bottle of propane and react with the O2, so it burns and release a smokeless flame and a great amount of energy and H2 and CO2, water vapor and carbon dioxide. And for this region, it's used for a fuel for motor engine and many type of industry. At the end, thank you with all my heart, and I hope you like it.